So the first example that we have here is x plus y plus z equals 5, 2x plus 3y plus 5z equals 8, 4x plus 5z equals 2. Now notice that the system of equations has three variables and it has 1, 2, 3 equations. That means my matrix is going to have 1, 2, 3, 4 columns because of the solutions and 1, 2, 3 rows. So it will be a 3 by 4 augmented matrix. Now I know in other examples in class on Wednesday and Thursday, our equations were x1 and x2 and x3, but because this process is a little bit different, meaning it includes the three variables, it's okay to leave them as x, y, and z. It's the same as if it were to be x1, x2, and x3, exact same process. So of course the very first thing we have to do is to write it in the augmented matrix format. So using my coefficients, writing your 3 by 4 matrix, we have 1, 1, 1, bar 5, 2, 3, 5, 8. In your third equation, 4x plus 5z equals 2, so 4 in the x, I have nothing in my y's, 5z equals 2. And so if you're missing a variable, like in the third equation, there's no y, you'd put a 0 in that column. So this would technically be our x, y, and z columns. So when we're solving a system of equations, when we're using when we're using Gauss-Jordan elimination, or whether we're using reduced row echelon form, we want this to look like the identity matrix. And we can definitely make sure that things are the identity matrix using the reduced row echelon form rules. And there were 4 of them, and those were on slide 2 of your notes earlier. We also looked at these exact same rules on Thursday in class. So the first rule says that each row of all zeros is below row without a 0. Since we don't have any zeros here, we can move on to the second rule. The second rule says the leftmost non-zero element in each row is 1. So in the first row it's 1. Okay. Second row, the first non-zero element is a 2. It needs to be a 1. So I have to change this 2 into a 1. Now, or I can change this 2 wants to be a 1. And this 4 needs to also be a 1. But according to my third rule, it says all the other elements in the column containing the leftmost ones are zeros. So in my first row, if I have a 1 here, that means that this 2 and this 4 need to turn into a 0. So let's focus on that first. Let's turn those 2's and 4's into zeros. So this 2, it's in row 2, so row 2. Remember that I cannot subtract a number, so I can't just say row 2 minus 2. If I'm subtracting 2, I have to subtract 2 of another row, so 2 times row 1. Since I'm just changing row 2, I can rewrite my first and the third rows to remind us that we're only changing that middle row. So row 2 minus 2 row 1. So 2 minus 2 times that same number in the first row is 1. Gives us a 0. 3 minus 2 times 1 gives us 1. And 5 minus 2 times 1 is 3. 8 minus 2 times 5, well 2 times 5 is 10. 8 minus 10 is a negative 2. I also want to change this 4 into a 0 so that I can fit my rule 3 for reduced row echelon form. All other elements in the column containing the leftmost one needs to be a 0. So since that's in row 3, minus 4 times row 1. Here, since I'm only changing the first or the third row, I can rewrite my first 2 rows. So doing the math here, 4 minus 4 times row 1 is 0. 0 minus 4 times row 1 is negative 4. And 5 minus 4 times 1 is 1. 2 minus 4 times 5. 4 times 5 is 20. 2 minus 20 is negative 18. So let's see, the leftmost non-zero element in each row is 1. So 1, and then the numbers in that column are zeros. Okay. Second row, that first number is a 1, but now I also want the other numbers in that column to be 0. So the 1, and this negative 4 need to turn into a 0. I can solve that, or I can complete that by doing yet another row operation. So row 1, well, if I want this 1 to turn into a 0, I'm going to subtract 1. So I'm really going to subtract row 2. So row 1 minus row 2. Since I'm just changing that first row, I can rewrite my second and third rows. So row 1 minus row 2, row 1 minus row 2, minus 3, and 5 minus negative 2 is a positive 7. I still want to change this negative 4, so row 3, to change negative 4 to a positive 0, I add 4 times row 2. Since I'm not changing rows 1 or 2 here, I can rewrite both 1 and row 2. So row 3, 0, plus 4 times row 2, another 0, is 0. Negative 4 plus 4 times 1 is 0. 1 plus 4 times 3, well, 4 times 3 is 12. 12 plus 1 is 13. And negative 18 plus 4 times negative 2. 4 times negative 2 is negative 8. Negative 18 minus 8 is negative 26. So, let's see. According to reduced row echelon form, the leftmost non-zero element in each row is 1, and then all other elements in that column containing that leftmost 1 are zeros. Okay. Second row, leftmost element is a 1, zeros above and below. Third row, leftmost non-zero is a 1, not quite. So this 13 tells me to change into a positive 1, I'm going to divide row 3 by 13. Again, I can rewrite the first and second rows because I did not change them. If I divide that third row by 13, 0 divided by 13 is 0, another 0. 13 divided by 13 is 1. And negative 26 divided by 13 is negative 2. So the leftmost non-zero element in that row is a 1. All the other elements in this column have to be zeros, which means this negative 2 and positive 3 have to turn into a 0. So doing yet another row operation, let's take care of that negative 2 first. It's in row 1. If I want negative 2 to turn into a 0, I have to add 2 times row 3. Since I'm just changing row 1, I can rewrite rows 2 and 3. 0, 0, 1, negative 2. Row 1 plus 2 times row 3. So be very careful with which row you're looking at when you do these row operations. So row 1 plus 2 times row 3. Well, 2 times 0 is 0, so 1 plus 0 is 0. Or sorry, 1 plus 0 is 1. Row 1 plus 2 times row 3. 0 plus 0 is 0. Row 1 plus 2 times row 1. 2 times 1 is 0, or 2. Negative 2 plus 2 is 0. And 7 plus 2 times negative 2. 2 times negative 2 is negative 4. 7 minus 4 is 3. And last but not least, taking care of that remaining 3 in row 2. Again, I want that 3 to be a 0, so I can subtract 3 times row 3. Since I'm just changing row 2, I can rewrite rows 1 and 3. So row 2 minus 3 times row 3, 0. Row 2 minus 3 times row 3. 3 times 0 is 0. 1 minus 0 is still a 1. 3 minus 3 times row 3. 3 times 1 is 3. 3 minus 3 is 0. And negative 2 minus 3 times negative 2. Negative 3 times negative 2 is a positive 6. So this is really negative 2 plus 6, which is a positive 4. So here, since our problem is given to us in XYZ format, that means my solution here is x equals 3, y equals 4, and z equals -2. Because I'm leaving it in XYZ format, then my solutions here are in x, y, and z form. So x equals 3, y equals 4, and z equals -2 would be your final answer. Notice, I know that because my matrix is in the identity matrix. My 1's go in the diagonal, and it fits all parts of reduced row echelon form. Each row of all zeros is below a row without a zeros. Well, I don't have any row of all zeros, so that can take care of that. The leftmost non-zero element in each row is 1. Check. All other elements in the column containing the leftmost one are zeros. Check. The leftmost one in any row is to the right of the leftmost one in the row above. Check. It's in reduced row echelon form. It looks just like the identity matrix, so I know for a fact that my solutions are x equals 3, y equals 4, and z equals -2.